Hello again, welcome to another lesson in geometry. Today we are covering section 10-3, area of regular polygons. All right, so this is going to be new for you. Let's get some vocabulary out of the way first. All right, so write true or false. In a regular polygon, all of the sides are congruent, and this is true. This is what makes it a regular polygon. Remember, a square is your basic quadrilateral regular polygon, and that's because we have 4 congruent sides and 4 congruent angles. An equilateral triangle is your 3-sided regular polygon because we have 3 congruent sides and 3 congruent angles, and so forth. So we always can have congruent sides and congruent angles in a regular polygon. So in a regular polygon, all angles are acute. This is going to be false. Okay. The only time that happens is in a triangle. Every other regular polygon has angles that are going to be obtuse, okay, or right. All right, so cross out the figure that is not a regular polygon. This is a regular polygon. Square has 4 congruent sides and 4 congruent angles. This is a regular polygon. All the sides are congruent, and if we went in here and measured, all of these angles are also supposed to be congruent. But this one's definitely not a regular polygon. Okay. All right, vocabulary builder. We have a new word here. Apothem. An apothem is words are center in regular polygon, and the apothem is a perpendicular distance from the center of a regular polygon to one of its sides. So let's just take a look at a regular polygon that we know a lot about, a square. Here's the center of the square, okay? And it's going to be, my apothem is going to be perpendicular to one of the sides. So like that piece right there, okay? All right, so underline a correct word to complete the statement. In a regular polygon, the apothem is the perpendicular distance from the center to a side, not an angle. Label the regular polygon using apothem, center, or side. So the center is that dot in the middle. Okay. A side is definitely the blue one here. Okay. And then the apothem is here. Apothem. Okay, on the top of page 2, we have problem number 1, finding angle measures. At the right, a portion of a regular octagon has a radii and apothem drawn. What is the measure of each numbered angle? So the radii in this picture are blue. Okay, so these are all these that go to the vertices. And the apothem is the red part that goes through here. Okay, splits one of those little triangles right in half. Okay, so a regular octagon, one more time, has 8 sides. Circle the type of triangle formed by the radii and the regular octagon. So each of these little triangles in here, okay, all the radii are the same length, so that's going to be isosceles triangles in there. They're not equilateral and they're definitely not right. Okay, all right, so use the justifications below to find the measure of each numbered angle. So the measure of angle 1 is going to be the 360 to go all the way around the interior of the polygon, okay, divided by 8 equal parts because it's a regular polygon. So 360 divided by 8 will give me angle 45 for angle 2, or I'm sorry, for angle 1. Okay, so angle 1 in here is going to be 45 degrees. Okay, that means all of those places in there will be 45. All of the parts where 2 radii come together to meet the center. Okay, so angle 2 is just half of that because the apothem splits that triangle, that isosceles triangle, right in half. So this is just going to be half of the measure of angle 1, and measure of angle 1 was 45, so when we split it in half, we get 22.5. All right, so I'm going to draw this out a little bigger here. So here is our equilateral triangle formed by these 2 radii. And here's the apothem that comes down through the middle, and that forms a right angle. So far, we took the 45 that was the whole top of that triangle and cut it in half and made it 22.5. Okay, now we're looking for this angle in here. Okay, all right, so it's going to form a little right triangle in there. So our angles are going to be 90 plus measure of angle 2 plus the measure of angle 3, and they're going to make a whole triangle, which is 180. And that's the triangle angle sum theorem. Okay, and then we can replace angle 2 with 22.5. Okay, that's the substitution. substituting it in. And then we can add these two together to make, what is that, 112.5? Still equal to 180. That's just simplifying the left side, so adding them together. And then we can subtract 112.5 to both sides, and we find out the angle of measure, angle of 3 in there is going to be 67.5. That's the subtraction property of equality. We're subtracting 112.5 to both sides. All right, so then we'll write out our final answers. So we knew that 1 was 45, okay? 1/8 of the whole 360 for the center. And then we split that in half again to get 22.5 for angle 2. And then we used the right triangle that's formed by half of one of those slices. And we knew 2 of the 3 angles, and we used the third one was 67.5, because the 3 of them together should have added up to 180. Okay. All right, postulate 10-1 and theorem 10-6. So postulate 10-1 says, if 2 figures are congruent, then their areas are equal. Okay, so this is a postulate because we can't really prove that. We just know that's true. If they're the same shape, then they have the same area. Okay. All right, so the isosceles triangles in a regular hexagon on the right are congruent. Okay, we're going to have all of them be the same. All right, so complete each statement. If the area of triangle AOB, that's this one. So if AOB is 24, we're asked, what is BOC? Well, BOC and AOB should be congruent, so they should both be 24. Okay. All right, our second question here says this. If the area of BOC is 8, so that one's 8, what is the area of AOC? So AOC is this shape, but it's formed by 2 of the BOCs. So this is going to be 16. Okay. All right, and then theorem 10-6, the area of a regular polygon. So the area of a regular polygon is half the product of the apothem and the perimeter. Okay. All right, so let's see why this works before we start doing a problem with it. So what's going on here is we had this shape, regular polygon. Okay, this part is right here, that isosceles triangle. And then since there are 1, 2, 3, 4, 5, 6 of them, we could build 6 identical triangles, okay, where the base of the triangles is the perimeter, and they all have the same height, which is the apothem. So the area of a triangle is the base times the height times 1/2. So there's our 1/2. There's the height of all the triangles, and the base of all the triangles is the perimeter of the shape. Okay. All right, so we're going to complete each one of these, find out what's going on. So if the apothem is 10 and the perimeter is 80, then the area would be 1/2 times 10 times 80. Okay. If the apothem was 5 and the perimeter was 30√3, then the area would be 1/2 times 5 times 30√3. Okay, and we don't have to work these out. We're just filling in the boxes. And if the apothem was 5√3 and the perimeter was 60, the area would be 1/2 times 5√3 times 60. All right, let's flip it over and look at the next page. All right, problem number 2, finding the area of a regular polygon. So what is the area of a regular pentagon with an 8 centimeter apothem and 11.6 centimeter sides? So all the sides are going to be 11.6. That's what makes it a regular polygon. Okay, all the sides are the same. Okay, and then the apothem, in this case, they tell us 8. So the apothem is drawn from the center of the regular polygon, so it forms a right angle with one of the sides. So in this case, there's actually 5 different apothems that we could have drawn. All right, so use the justifications below to find the perimeter. So our perimeter is equal to n times s. Use the formula for the perimeter of an n-gon. Okay, so n times s. Well, that's side length of n. Okay, how many sides do we have, which in this case is 5, times one of our side lengths, which was 11.6. So 5 times 11.6 will give us a perimeter of 58. Okay, so use the formula for the perimeter of an n-gon. So the n-gon had n sides, and each side was s long, so n times s. Okay, and then we substitute it for n and s, and we simplified it. All right, so use the justifications below to find the area then. So remember, our area is 1/2 times the apothem times the perimeter. So we knew our apothem already, it was 8. We know our perimeter now, it's 58. So half of 8 is 4, and 4 times 58 will give us 232. So our answer here is 232 centimeters squared. So this is just use the formula, substitute in for the apothem and the perimeter, and then simplify. Problem number 3, using special triangles to find the area. So we got to think back to our special triangle stuff. It's going to be important for us. All right, so the sides of a regular hexagon is 16 feet. What is the area of the hexagon? We're going to round our answer to the nearest square foot. So I know the length of each side of a regular hexagon is going to be 16 feet. Okay. What do I need? Well, I still need the perimeter. And I still need the apothem. Apothem. Okay, so I got to find those two things. All right, so draw a diagram to help find the length of the apothem, and then use the perimeter to in the area formulas to help you out. Okay, so to get the final answer. So here's our diagram. Here's a regular hexagon. It has 6 congruent sides and 6 congruent angles. Okay, and then we're going to cut off a couple slices to show what's going on. So one of the slices is going to have 60 for the interior angle right here, and that's because there's 6 interior angles, and if we divide 360 by 60, we're going to get a total of 60. So each interior angle in there is 60. But then we can cut that in half again to get 30 in this part. Okay? All right, so we can put in some sides that we know. We know that each of the whole sides is 16, but here they're asking for halfway over, so that's going to be 8. Now, why are they doing half? Let's think about that for a second. What that formed is, here's the apothem. Okay, here's one of the radii that touches it, and here's half of the side. So I knew this 8, I knew this was 30, and this was 90, so that means that's a 60. So I can use the special 30, 60, 90 triangle to find the length of the longer leg. That's that red part. And that longer leg is the apothem, and that's the important part we need. Okay. All right, so circle relationship you can use to find the length of the apothem. So remember, this extended ratio for a 30, 60, 90 triangle is x. The hypotenuse is 2x. And the long leg is x root 3. So that's going to be this one. The longer leg is equal to root 3 times the shorter leg. Okay, that's the one we need because we don't care about the radii length. We want to know the apothem length. All right. So the length of the shorter leg is 8. Therefore, the length of the apothem is 8 root 3. Okay, and we're not going to work that out. We're going to leave it right where it is because we're not going to round to the very end of the problem. All right, so we can certainly find the perimeter of a regular hexagon. A regular hexagon has 6 sides, and each side length is 16 in our case. So 6 times 16 will give us 96. Okay, so there's our perimeter. So now we have all the parts we need. We have the apothem and we have the perimeter. So we'll flip it over and finish this up. So if we find the perimeter and the apothem, we can use our formula. So the area is equal to 1/2 times the apothem times the perimeter. So 1/2 times 8 root 3 times, and I forgot the perimeter already, it was 96. Okay. And that's what's going to be for works out exact answer, but we don't have to find an exact answer. All we have to do is type this on our calculator and round to the nearest square foot. So this is going to be about 665 when I round it. Okay, so 665 square feet. All right, so as always, pause the video, try the lesson check yourself, and then come back and look it over. All right, welcome back. So what is the relationship between the side length and the apothem in each figure below? Okay, so this is our apothem in a square, and that's our side length. Okay, So let's get our problems here. And then in a regular hexagon, we have this side length and then the apothem coming down to it. And in an equilateral triangle, we have this side length and then the apothem coming down to it. Okay. So the radius and the apothem form what type of triangle in each figure? So in our first figure, we get this triangle over here where it's a 90 and a 45. So that means this is a 45, 45, 90 triangle. In our hexagon, we get this one right here, which is a right angle, a 30, and we also must have a 60 there. So that's a 30, 60, 90 triangle. And in an equilateral triangle, we get 60 up here and a 30 and a 90. So that's another 30, 60, 90 triangle. Okay. All right, complete to show the relationship between the side length and the apothem in each case. So in our case, the apothem is exactly half of the side length. Okay, because we could cut the side length in half to form our triangle. And we know that for a 45, 45 triangle, 90 triangle, the two legs should be the same. So the apothem is going to be half of our side length. In a hexagon, okay, we have a 30, 60, 90 triangle in there. And the 30 across is half of our side length. Okay, across from the 30 is half of the side length. So the small side is 1/2 of the side length. And then our apothem is the longer leg here. So if this is x, remember this one has to be x root 3. So this is going to be root 3 times half of our side. Okay, because x was half of the side. So that will make root 3 over 2 times s. And in our last one, we still have half of the side, but this time it's the big leg. Okay, so this is our x root 3, and the apothem is the small leg, so that's going to be our x. Okay, so the longer leg is root 3 times the shorter leg. Okay, and that means half of our side is equal to root 3 times our apothem. And then we can solve for the side to get it all the way into it where the sides are the same. So this will be times both sides by 2. And we can say our side is equal to 2 root 3 times the apothem. Okay? All right. So these are the relationships between the angles, or the apothems and the sides. And they could have put the apothem, I think they should have put the apothem on its own side here like they did in the other ones, but it still shows the relationship. All right? So check off the vocabularies that you understand. So hopefully you know what the radius of a regular polygon is. Remember, that's from the center, let's draw the easiest regular polygon, the square, to one of the vertices, that's a radius. And hopefully you know what the apothem is. That's from the center, so it forms a perpendicular with one of the sides. Okay. And then rate how well you can find the area of a regular polygon. I'm guessing most of you are somewhere in here. It's a little tricky to find the length of the apothem. Okay, so you have to do some special math in there. Okay, we'll also have some trig to run into when we're finding it in class next time. So I'll see you next class.